So midpoint theorem, unit number 11. Okay, tell me something. What we call midpoint theorem? Can anyone tell me? What is midpoint theorem? Can anyone tell? Soon. What is midpoint theorem? Can. What is midpoint theorem? Soon tell me. It's an easy one, right? Someone try quickly. There are two things, right? There are two things. One is the midpoint theorem. The second one is the converse of the midpoint theorem. Converse, or we call inverse, right? And the other thing what you must need to know in the midpoint theorem, right? So this is coming under geometry, no? Geometry, we have studied a lot about angles, right? About what do you call angles. Then we've studied about the parallel lines. Okay, parallel lines in between, and then parallelograms in between parallel lines, right? And the triangles, right? That means to find the area, right? Then what else we have? So like that in geometry, we were studying a lot, right? About angles, then about alternative angle, corresponding angle, if parallel lines are there, how these are there, right? So lots of things, starting from congruency from grade 10, we're studying a lot, right? We study lots of things. Now, this is the next step, right? This is the next step what we must need to know in this lesson, right? In the geometry part, because geometry part consists of nearly like 25 marks, right? Nearly like 25 marks out of 100 marks in your paper. That is a little bit more also, right? Okay, so like that, you must need to know about the midpoint theorem, right? Okay, now midpoint theorem is a theorem which applies for triangles, right? Which, like, it can be any kind of triangle. So I'll take two, right? I'll take two types of triangles so you'll understand. This is one type, this is another type. Two shapes, right? Okay, so in the midpoint theorem, what they're telling is, right, I will make you this easier. How? I'll take one side as this is the first side, right? This is the second side, and this is the third side. Okay, one side, first side, second side, and the third side, right? Okay, right. Now, here what I'm going to tell is, right, if I draw a straight line, by connecting the midpoints of first and second side, So here in the first side, this is a midpoint. In the second side, this is a midpoint. If I draw a straight line which is connecting the midpoints of first and second side of two sides, or first and second side, this straight line is parallel to the third side, and right, this line is right half the value of the third side. That means if this is x, if this length is x, this length will be 2x. That length will be 2x, right? So again, I will tell you the theorem, right? If there's a straight line drawn in between the midpoints of two sides of a triangle, and that line is parallel and right half the value of the third side. So whenever you want to get this midpoint theorem, what you have to do is just draw a small sketch, right? Just draw a small sketch and then you try to get the idea, right? So that will be very easy to get the midpoint theorem. So what is it again? I will tell you, right? If you draw a triangle, mark 1, 2, and 3 like that. Then whatever, whenever you want, until you get the practice on this, so after that you can easily advance, you can write. Okay. So to get the idea, what is it? This side's midpoint and this side's midpoint, right? What is joining? A straight line. A straight line segment which joins the midpoint of two sides of a triangle that is parallel and right half means half of the value, right half of the value of the third side. So this line will be parallel, and this side, if this is x, this will be 2x, or if this is 2x, this will be x, right? So this is a theorem, right? This is a theorem. Now, wherever we can see something like that, okay, if two midpoints are there, and if there's a line like that, not without doing anything, right? So directly I can come to a conclusion. This, like, if this side is 10 centimeters, this is 5 centimeters, no? And this is parallel, and this line definitely should be parallel, no? So like that, I can come to a conclusion, right? That is why these theorems are there, right? Okay, this is one thing. The next one is, okay, he also will do the same thing, right? I'll take, this is the first side, this is the second side, and okay, that is usual. This is the second side, and this is the third side I will take, right? Now what I will do, for the first side, I will mark the midpoint here. For the second side, I will mark the midpoint, it is here, right? You see, a straight line segment which joins the midpoint of the first side and the second side, that means for two sides of a triangle, that line segment is parallel to the third side, and that value is right half of this length. So if this is 10 centimeters, this is 5 centimeters. Is it clear? Is it clear, friends, students? Can you hear me?
Yes, sir.
Yes.
Is it clear?
Yes, sir.
Is it clear? Right, fine. Okay. So this is what we call the midpoint theorem. The theorem. Okay. Right. Soon
Yes, sir.
put the topic. Soon put the topic. Right. First we'll see the theorem, and then we'll see the inverse. Right. Inverse or the converse. Soon write the topic. Right. Write the subheading theorem. 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 Done?
Yes, sir.
Right. Then write the first point of the theorem. The straight line segment. The straight line segment. Straight line segment. Next line. Next line. Straight line segment. Next line. Okay. Next line. Through the midpoints of. Through the midpoints of. Can you see? Through the midpoints of. Only intelligent people can see. Through the midpoints of. The straight line segment through the midpoints of. Right? A triangle. A triangle. A triangle. A straight line segment through the midpoint of a triangle. A triangle. Next line. Next line. So triangle is parallel to the third side. The third side is parallel to the third side. Is parallel to the third side. Next point. And equal in length. Equal in length to half of it. To half of it. equal in length to half of it. Okay, I'll repeat it again. First point, the straight line segment, right? Next point, through the midpoints of two sides of a triangle, through the midpoints of two sides of a triangle. Next line, is parallel to the third side, fourth point, and equal in length, to half of it, the third side. So this straight line segment is equal in length for half of the third side. Read it again, Sue. Read it again. Done. Right. Okay. So write the example number 1. Example 1. This is example 2. Draw it. Right. Soon, right. We must need to understand one thing. Now, here when we study these things, this is very easy, right? Midpoint theorem, that is very easy now. Okay, like that we can understand. But you see, when you want to prove that, nicely you want to prove it, right? You want to think the examiner is like a baby, right? That is the first thing. Examiner is a baby, right? That means he is not knowing anything. He is not knowing anything. So, like if if I saw something, right? How I will going to explain to a kid, small kid, right? Okay, I'm seeing a tree, right? I want to explain to a kid, right? Okay, can I tell that is tree is that? If I tell like that, that is, these can't understand the fellow, right? So I want to, right? The tree that is starting from its roots, okay? Its roots, okay, then it comes to its stem, right? And then having branches like this, right? In the branches, that also dividing into several branches, right? And these corners of the branches and everywhere, there'll be like this shape, small leaves will be there. That leaves are in green color, right? Okay, so lots of leaves will get together to form nice structure like this, right? Okay, and the bark of the stem is brown in color or dark, right? And there will be several roots, right? Okay, which is going underground. So like this structure is what we call a tree. Like that, like how we explain something to a kid, like that we want to explain these geometry parts, right? When we want to write answers, right? So they will ask, right? Show that PQ is half of this FQ. So what we can do, right? First of all, after if we draw, we want to mark like using some symbols like that. Then to prove that what PQ is half of FE, right? Then not will write the proof we will write. So one by one I want to write, right? P is the midpoint of DF. Done. Keep it aside. The reason, you have to write the reason in the brackets. They have given or something like that, right? Okay, and then they will tell, I want to tell Q is the midpoint of D and E. I can write. Okay, data, right? Or given something like that. I can write the second reason. Third one I'm writing, right? Therefore, if straight line segment of PQ is joined, right? PQ is joined, right? Then you can write nicely what? PQ parallel to FE, right? The inside the brackets you can write the midpoint theorem entirely. You have to write the straight line segment joining two midpoints of a triangle. Two midpoints of a triangle is parallel to the third side of the triangle, and it is right half of the value of the third side. So we are trying the entire thing inside the bracket. So likewise, for what they are asking, one by one you have to clarify and go, right? So like that, you have to explain by thinking the person I'm going to explain this answer is not knowing anything. Therefore, step by step, one by one, I want to tell that, right? So like that only we have to think and we have to prove it. Okay, I finished drawing this. Are you done?
Yes, sir.
Right. Is it clear? Is the midpoint theorem is clear?
Yes, sir.
Right. Okay. It is clear.